Hey mathematicians, so in our previous lesson we learned about properties of equality and those were used on the reason side of our proofs. Today I'm going to give you more things that you can use to justify your steps when you're writing proofs. So the first thing I'm giving you, or the first definition, is segment addition postulate. This states that if 3 points A, B, and C are collinear and B is between A and C, then AB plus BC equals AC. So let me give you an example. I'm going to draw a line the best I can. All right. I've got A and B, and C, and B is supposed to be in between those two. So segment addition postulate is just saying that whatever the measurement from A to B is, if we add that to whatever the measurement of from B to C is, then it's going to give us the entire measure of that segment. Alright, so now we'll talk about angle addition postulate. The angle addition postulate states that if point B is in the interior of angle AOC, then the measure of angle AOB plus the measure of angle BOC equals the measure of angle AOC. So let me draw that for you. We've got an angle. The angle is AOC. B is on the inside of that angle. And an angle addition postulate is just telling us that whatever the measure of this is, if we add that measurement to whatever the measure of this part is, then that's going to give us the measure of the entire thing. So that's angle addition postulate. Alright, the definition of congruent segments. This states that if AB, segment AB, is congruent to segment CB, then AB is equal to CD. So if you know what congruent means, congruent just means that their measures are the same, and that's what the definition of congruent segments is saying. It's saying if we've got this going on, I'm going to draw two different segments. I'm going to name them A and B and C and D. And it's saying if those are congruent, then that means their measures are also equal. Alright, the definition of congruent angles. This states that if angle DEF is congruent to angle XYZ, then the measure of angle DEF is equal to the measure of angle XYZ. So this is very similar to the other congruence statement. So I'm going to draw some pictures. We've got DEF and XYZ. So if I'm saying that these two angles are congruent, then the definition of congruent angle says that I can also state that their measures are equal. Alright, the definition of angle bisector. A bisector is something that cuts something into two equal parts. So this states that if AB divides an angle into two congruent angles, then AB is an angle bisector. Alright, so that would look something like this. Alright, so this middle line right here is considered an angle bisector because we've got two congruent parts on each side. Alright, the definition of midpoint. This states that a point that divides a segment into two congruent segments. So let's draw a big segment, A, B, C, and instead of using the congruent symbols and marks, I'm going to use numbers. So I'm just going to put 6 here and 6 here, just so that you can know those are two congruent segments. And that's what midpoint means. Alright, the next part. These last ones were actually on the video, the vocabulary video. So the first one is definition of a linear pair, and this says two adjacent angles formed by two lines or segments. So let me draw a picture for you. Here you go. All right, the linear pair postulate states that two angles that form a linear pair, so these guys I drew earlier, are supplementary. So I'll just put like 130 here and 50 here just so you can know that those equal up to 180. All right, but then that takes us to the next part, supplementary. The definition of supplementary states that two angles whose measures have a sum of 180 degrees. So kind of the same as this. All right, and that's all the vocabulary that you guys need to know for today's proofs.